All right, so again, as we talk about heat and energy and things like that, the way that we represent energy in our uh, formulas is going to be with the variable Q. Okay, so Q represents heat energy and it moving. Okay. Now, whenever we measure something in chemistry, we're always going to obviously have a number, and we have to put the units of measurement for the number. So let's say, for example, the amount of energy that goes into something is like 100, right? But we need to describe that with the unit of measurement, and the way that we measure energy is through joules. So similar to what we've been doing with our thermochem stoic, instead of kilojoules, it's joules, smaller unit of measurement, but we measure it in joules. Okay, so heat energy is represented by the variable Q, and we measure the numbers with joules. Okay, so just make sure you jot that down somewhere as well. If you ever see a number with joules next to it, that's going to represent heat or energy moving around. All right, so let's talk about the new info for today. So today we're going to be talking about something called specific heat, and the variable for that is going to be the letter C. Okay, and specific heat is basically, I'll give you the definition, I'll explain in a second, but it's how much energy you need to raise the temperature of 1 gram of something by 1 degree Celsius. Okay, so it's how much energy you need to raise the temperature of 1 gram of a substance by 1 degree Celsius. Just make sure you jot down the definition, and then we'll talk about that in just a second. All right, so if you guys take a look at the first column on this table, you guys are going to notice that there are different substances, right? We got nitrogen gas, we got aluminum, we got iron, we got mercury. Now, if you guys take a look at the other side of the table, the right side, you'll notice that there's a number associated with that substance, right? So basically, this number tells us the specific heat of this substance. Okay, so just to kind of help you guys visualize, I want you guys to jot this down on your notes, but I want you guys to draw like a balloon. Okay, we're going to call this N2. Okay, this is N2 gas. And let's say that we have 1 gram of N2 gas. So we have 1 gram of N2 gas. Now, you see how the number right here is 1.04, right? So if you put in 1.04 joules of energy into this gas, that means it's going to increase the temperature by 1 degree Celsius. Okay, so that's pretty much what specific heat is. All right, so this is the equation for calculating specific heat. Now, there's 2 forms. I want you guys to write down just the top one for right now, and I'll explain it in a second, okay? But I know it's a little weird now that we got shapes in our equations, but I'll explain what that means in a second. It's actually pretty easy. It's just regular algebra. But copy down this first equation, and I'll break down all different components, and then we'll use it in some couple practice problems, and we'll be good. All right, so if we take a look at the equation right here, let's start with the first one, Q. Okay, Q represents heat energy. We talked about that earlier, right? So this is going to represent the heat. And the way that we measure Q, so the number that goes in for Q is always going to have joules following it. Okay, so Q is going to represent heat. The number is going to have the units of measurement, joules. Alrighty, let's look at the next one. We got C. We talked about C already as well. This is going to be specific heat. Okay, so, and this is going to depend on what substance you're looking at. Everything has a different specific heat. It's how much energy you need to heat it up, basically. All right, let's go to M. M is pretty easy. Okay, it's mass. And if you guys remember from the previous units, we always measure mass in grams. All right, and then we have our last variable. Now, if you guys, the last variable is going to be a triangle and the T. This is delta, it's Greek alphabet. But delta T tells us the change in temperature. Okay, so basically, how much is the temperature changing? Is it going up by 10 degrees? Is it going down by 5 degrees? Okay. The change in temperature of an object, that is represented by delta T. So that's going to be that equation. I'll show you guys how to use it in a second. Now, I do want to go over this other version of the equation. If you guys look down here, there's a second one, right? But if you notice, it's pretty much the same thing as the top one, right? You got Q, you got C, you got M. Okay, the only thing that's different is the temperature stuff, right? So this first equation, we use it when we know the change in temperature. So the problem tells you, hey, the object got 10 degrees hotter, or it got 20 degrees colder. But for this one, we use this equation when we have two different temperatures. TF represents the final temperature, and TI represents the initial or the starting temperature. Okay, so we use these different equations depending on what information we're given. If we're given how the temperature changes, just to change, we use the delta T equation. If they tell us, hey, you started at 10 degrees and you went to 50 degrees, if you know the final and the initial, that's when you use the second equation right here. But it's pretty much the same. The only thing different is the temperature stuff. All right, so let's take a look at number one. First thing we're going to do is we're just going to look at the numbers. It says it takes 209 joules. So I'm going to pause right there, okay? Now, if you have joules, which one of these variables is represented by joules? Yeah, Q, heat. So let's just write on our paper some more. Q is going to equal 209 joules. Okay, Q is 209 joules. All right, let's move on to the next one now. It says it takes 209 joules to increase the temperature of 50 grams of water. Now, if you take a look at 50 grams, which one of these variables is grams? Not triangle T, it's mass. Mass is grams, right? It's how much something weighs, how much of something you have. So for the next one, let's write M equals 50 grams. So that's the trickiest part of these problems. It's just figuring out what variables to plug these numbers into. And then lastly, it says to increase the temperature of 50 grams of water by 1 degree Celsius. Now, if we take a look at this phrasing, it says by 1 degree Celsius. Okay, is this giving us information about how much the temperature changed, or is it telling us the final and initial temperature? That says it goes up by 1 degree. What do you guys think? It's too early for this, huh? Yeah. So if you ever see one temperature and it says by, you'll know that it means the change in temperature, because going up by 1 degree Celsius. It's not telling you that it starts at 1 degrees or ends at 1 degrees. It's just going up by 1 degree Celsius. So that's going to be delta T. So for this problem, we are going to be using Q equals CM delta T. All right, so let's plug our numbers into the equation, and then after that, we'll solve. Okay, so let's plug in our number for Q. Q is 209, so we're going to plug in 209 joules equals. We are looking for specific heat because that's the only one we don't have a number for. Also, the question says, what is the specific heat? So we're solving for C. Our number for M is 50 grams, so we're going to plug in 50 grams. And then the delta T is 1 degree Celsius. All right, guys, so this is pretty simple algebra from here. So I'm going to give you guys about 2 minutes. See if you guys can plug this into your calculators and get your final answer for variable C. Take a second, try that out, and then we'll go over the answer together. Okay, so if we take a look at our equation, it's just regular algebra, okay? So we want to isolate C. It's basically the same thing as your math class. If you're solving for a variable like X, how do we solve it? That's what we're doing here, okay? So first thing we want to do is we want to simplify the stuff on the right side. If you look, it's 50 times 1, right? Should be pretty simple. So on the right side, we have C times 50. I know, incredible, right? All right, now we got 209 on the other side. How can we separate the C and the 50 if they're being multiplied? Yeah, divide by 50. That's it. You divide both sides by 50. Okay, the 50s will cancel out. And on the right side of the arrow, all you have left is C. And so all you need to do to solve this is 209 divided by 50. Okay, yeah, it's 4.18. I trust you guys. But just to check, because I don't really trust you guys, 209 divided by 50 is 4.18.
Can you just skip everything instead of doing 95 by 50? That's right.
Yeah, you can do that, but then you were asking me for help earlier, so I want to make sure we go over all the steps, you know?
Oh, okay.
Yeah. Did you know that this is the division symbol? You click this button on your calculator, okay? Yeah, just so you know. All right, any questions about that, guys? Alrighty, guys, let's try another one. Hopefully that was helpful. It's very similar. All we're doing is just solving for different variables in this equation. So, let's go to the next one. Okay, I want you guys to try this one with the person next to you. Okay, same thing as before. You want to figure out what variables all the numbers are, and then you want to plug it into one of the two equations. Okay, so you got to figure out to use the delta T or the final temperature and the initial temperature equation. Try that out. Give you guys about 2-3 minutes, and then we'll go over it together. Okay, so if we take a look at this problem, let's start with the numbers again. We have 15.75 grams. So hopefully you guys are able to tell grams tells us that it is mass. Okay, so this is 15.75 grams. Okay, it tells us that it absorbs this much joules of energy. Okay, if you ever see joules, that's going to be Q. So 1086.75 joules. Okay, and then here it tells us the temperature goes from 25 to 175. So if you guys look, we're not finding how much the energy changed or the temperature changes. It tells us the starting temperature and then the ending temperature. So that means that we're going to be using the TI-TF one. Okay, TI, the initial temperature is 25 degrees Celsius, and TF is going to be 175 degrees Celsius. All right, so for this example, we're going to be using the second equation. We're going to be using the Q equals CM and then parentheses TF minus TI. Okay, and the question says find specific heat. So we are looking for C again. All right, so let's plug in our numbers and then we'll be all done. So Q is this big long one right here, 1086.75 equals, we're looking for C. The mass is 15.75. And then in the other parentheses, we have TF, which is 175 minus 25. Okay, so again, this is just pretty simple algebra. All we got to do is plug our numbers into the calculator, and we're all done. Okay, so let's start with the parentheses because we got 175 minus 25. And if you guys remember the order of operations, we got to do parentheses first. So 175 minus 25. Hopefully you guys got 150. Okay, so this is going to be 150. 175 minus 25 is 150. All right, next step, what we're going to do is we're going to multiply 15.75 and 150. Same thing as before. Multiply the stuff that's on the same side. So on the right side of the arrow, you're going to get C times 2,362.5. And that's going to equal 1086.75. All right, and then same thing as before. If you want to isolate C, what you want to do is you want to divide by the number that it's next to. So you're going to divide both sides by 2362.5. These guys cancel out. And that way we're able to see that C is equal to 1086.75 divided by 2362.5. Okay. You got 1086.75 divided by 2362.5. Okay, final answer is 0.46. Okay, so to heat up 1 gram of iron by 1 degree Celsius, you need 0.46 joules of energy. That's pretty much what our calculations are telling us. Alrighty, so if you take a look at this problem, it's asking us how much energy. Okay, so we're starting by looking for energy. Okay, so in this problem, we're looking at energy. So that means that we are looking for Q in this problem. Okay? Okay, so it's looking at energy, and it's asking how much energy do you need to raise the temperature of 50 grams, and so our mass here is 50 G. And then it's asking us or telling us that it's liquid mercury. Okay, so if you guys take a look at this table, we got liquid mercury right here, and it tells us the specific heat is 0.14. So that means that C is going to equal 0.14. So that was the trick here. Since we're looking for Q, we need C. And then liquid mercury, it tells us that 0.14. So we can get that from the table. And then it's telling us the temperature is going up by 82 degrees Celsius. Okay, so that's going to be delta T, because it's going up by 82. It's not starting or ending at 82. It's going up by 82. So delta T is 82 degrees Celsius. Okay. All right, so we're going to be using the first equation, the Q equals Cm delta T. So we just plug it in. We're looking for Q, so we'll leave Q like this. Our C is 0.14. Our M is 50. And then delta T is 82. Okay, so the math is really easy here. We don't need to move anything to the other side of the equal sign. All we got to do is just straight multiply. Just plug it into our calculator. Okay, so on our calculator, we just do 0.14 times 50 times 82. There you go. Our final answer is going to be Q is equal to 574. And since it's energy, it's going to be measured in joules. Okay, so if you guys notice, it's just basic algebra. You're just looking for the missing variable using the info you got. And that's it.